Okay, today we're kind of skipping ahead. We're going to lesson 10. There's just, again, things that got cut out of our curriculum this year, or out of our standards, so we're not going to worry about it. So today we're going to I'm going to explain a little bit about what's the difference between similar and congruent. We're also going to learn one way to determine if a triangle is similar, and then I'll give you a couple problems to practice with, and then you should be good for your homework. So when we're talking about similar versus congruent, so last module we talked about congruent. Congruent would be you have a triangle, if I can get this pencil to work. Congruent would be you have a triangle and another triangle. Now when you have these triangles, they are the exact same. Okay, so congruent means that, let's say the side length on all these is 1, then that's going to be the side length for all of them. Obviously the angles would be the same, all of that would still apply. So that would be congruent. Congruent means exactly the same. Similar, on the other hand, is going to mean that they're similar, they're not the same, they're proportional to each other. So on the last Khan Academies I gave you, we had some proportions where I said 3 over 4 is equal to what over 12. So when we solved those, we had to cross multiply and all that, but we ended up finding out that x would equal 9. So that was actually a good setup for what we're going to do. So when we talk about similar, in this case we'll look at similar triangles, we would have a triangle here that'd be small, and then we'd have another triangle where the side lengths are bigger. Okay, so the side length should be proportional. That means if all these are 1, then this one would be, let's say 3, 3, and 3. So if I was to compare this side length with this, these side lengths, so it's 1 over 3, that should be the same as if I did this side length and this side length. And as we can see, they're the same. So when we're looking at similar, they need to be proportional. They need to be kind of like what we were having up here. It's not going to be the exact same, and there'll be a couple of things that we'll talk about moving forward that will help us to determine if they're similar or not. But this proportional relationship should show. So like if I was going to have this one and then compare it to this one, the ratio between them would be 3. I took a side of 1, multiplied it by 3, and now I have a side length of 3. And I did that for all of them. So another example is if I had something like this. There's one triangle, here's another triangle. Again, we're going to say they're similar. My artistic ability does not say that. But, so let's say we had a side 2, 4, actually, I'll do a 3, 4, 5. So 3, 4, 5, and then this one will be a 6, 8, 10. So these ones are similar. It's actually, these are both right triangles. So we have a 3 divided by 6 is going to equal 1/2. So if we're going to go from this one down, then we multiply by 1/2. And we could do the same here. So 4 over 8, that also equals 1/2. So far we're so good in showing that they are proportional. And with the last one, 5 divided by 10 equals 1/2. So this would be what we're looking for. All of the sides are proportional to each other. All of them have the same ratio when you take the side that's the same. So that's what we're looking for, and that's just kind of a quick intro to what is similar versus congruent. Congruent would be they're all the same. Similar, they're going to have proportional sides. This is just working with triangles. If we looked at circles, all circles would be proportional or would be similar to each other. Squares would all be similar to each other. So there's just a couple things we'll look with there and practice in the future. Okay, so one that we're looking at today, it's called angle. This is actually something that I use quite a bit in geometry. We're going to kind of get in, an introduction today. It's pretty simple to use, but it's a really quick way to see, okay, are these similar or are they not? So right here I have drawn pretty parallel lines. So these lines, when I mark it like that, that's just saying that they're parallel. So these lines are parallel to each other, and I drew straight lines across. So you'll see right here that I have triangle 1 and a second triangle on this bottom part. Okay, so we're going to see if these triangles are going to be similar to each other. So one way that we can do this is by looking at angles. So if we have this angle right here, okay, there's another angle that's going to be corresponding to that. So using what we know about parallel lines, we can actually see that, okay, this one down here is the same. So if we draw out our triangles, we have this one, it's A, B, C, and we have our other triangle, it's a bit bigger. Again, A, D, E. We can see that these two angles, because they're both corresponding, are going to be the same. So that's one way we can look at it. So that's one angle. So it's angle, angle. We need two angles. The other angle, we could just use A. A is the same for both. It's the angle they share. And I'm using two lines so you can see that it's a different angle that we're measuring here. But we also have this angle here. So 1, 2, 3. This angle right here, its corresponding angle is going to be on the inside down here. And they're going to be the exact same. So again, this is just using what we know from parallel lines and the relationship of the angles. These ones are going to be congruent. So if on triangles, if we find that all of the angles are the exact same, then that means that we have a similar triangle. So the reason is each one of these sides is connected. Remember when we did the Pythagorean theorem, you had angle A, angle B, angle C, and I said this one you go across and you find little a across little b and little c. That's because on triangles, every side has a relationship with the angle. So as long as we have our angles being the same, then we'll have similar sides. They're not always going to be the same, but they'll be proportional to each other. So what we're going to look for in this lesson is trying to find, okay, are the angles similar? And if they are, then we know, okay, cool, we have similar triangles. So let's take a look at this one, this first one here. So I'm going to do 3, and then I'll give you a little bit of time to go through 4 and 5. So, are the triangles shown below similar? Present an informal argument as to why they are or are not similar. So, if we look at these ones, first thing, it's kind of nice that they tell you this is angle A, or point A, but we can really refer to it as angle A prime, and A. So those are the ones that are going to match. Okay, and then we can come down here, B and B prime, C and C prime. So if we wanted to, we could look at this and say, okay, what would be this final angle here? What would it equal in each? So I do 103 plus 31. That's going to equal 134. So we subtract that from 180, and we're going to get 46 degrees. So I know this one's 46 degrees. I then can also look at this one here and say, okay, 103 plus 31, that's going to equal 134. When you subtract from 180, that's 46. This one also is going to be 46. So since all of them are the same, then we know, okay, these are similar triangles. So are the triangles both similar? Yes. All angles correspond. I think I spelled that wrong. Yes, I did. I'm sure I'd mess up this front part too. So all angles correspond to each other. And really for me, that's all you would need to write. So yes, it would be work, that one would work. All the angles are the same. Okay, so I'm going to give you a little bit of time. I want you to practice 4 and 5 and then see, are they similar triangles? And then just give a quick explanation as to why or why not. Okay, so I hope you took some time to try them, just look them on your own. So this first one here, number 4. So again, we match up our angles. I will say sometimes you have to be careful. Sometimes they won't tell you the angles. I know in the future there probably will be times where I don't tell you the angles and I don't tell you which ones match up. I'll just give you 2 triangles and say, are they similar or are they not? So on this one here, we're going to look at these. So we're lucky here, it gives us angle A prime, B prime, C, and C prime. So when we look here, 31 degrees, okay, that's good. 85 degrees, 103, that's not seeming right. We could always check. We know that this one here is 46 degrees. You know, maybe this is a different angle, but these ones right here, none of them match that 85. So no, not all angles are congruent. I think that's how you spell corresponding. Okay, so no, not all angles are congruent to their corresponding angle. So I guess I should probably say up here, all angles correspond or are congruent to their corresponding angles. Angle. So I probably should change that. I would change that if I were you, because they're congruent. So, you know, congruent just means that they're equal to each other. So down here, now all of a match. We do have one that matches, but the other two don't. So it's not going to be a similar triangle. Okay, on 5, are the triangles shown below similar? So let's look. Okay, we have angle A and A prime. Those ones are congruent. So you can also write out angle A is congruent to angle A prime. And then, okay, so B and B prime, well, those we don't have anything. So this one, I really like that they put it in here, because it actually gave you angle C, which matches with C prime, and we don't know necessarily, we don't have two that match up. But what I'm guessing is some of you looked at it and said, okay, 72, 60, 72, 48, nope, that's not it. But we really do need to double check that that missing angle isn't what we're looking for. So then we can do, let's do this one down here. So 72 plus 60, it's gonna be 132, and then we'll do 180 minus, 180 minus 132, so that'll give us 48. So this one down here is 48. Okay, do we have two of our angles matching up? Yeah, we do. We have 72, 72, 48, 48. That means that last one's gonna be 60. So we would say yes, all corresponding angles are congruent. Okay, so that's what we're looking at. When we're going through these, you're just going to determine and look at the angles. Okay, are they similar? Are they not? I don't think on the homework you have to do anything with the ratios and actually figuring that out or determining the missing side length. All we're doing is looking at the angles. So, like I said, hopefully this is an easier introduction into similar triangles. This is something that I know will come up this year. We're going to use it for slopes, but also in the future when you get to 10th grade, we're going to use this. You're going to use it again to determine some similar triangles there. So that is all.